Well, it's time for the dreaded, not the dreaded Mars hour, but the great Mars hour. We're gonna sort of have a little breakout hour now, I think, aren't we? You should
Yes.
explain what Mars hour is.
Yes, so an hour for you to do activities. And we will continue here. We're going to talk to lots of fascinating people.
Yeah.
And I'll talk about some of those in a second. But hopefully you've already got some resources to do some activities. If not, there'll be a link that will be dropped in the chat shortly. So you can go to that link and find some resources for some activities for you to do.
The reason I said dreaded Mars hour, because a Mars hour is slightly different to an Earth hour.
Yes,
isn't it?
slightly
Can you explain why and what the difference is?
Mars's rotation rate is slightly different from the
Okay.
Earth's. And so an hour on Mars is 1 Earth hour plus 1 minute and 36.963 seconds.
So our Mars hour will be that. And the reason I said dread it, because weird things pop into my mind suddenly. And I was thinking to myself, it's when the clocks go back here on Earth and you have to change all your clocks and you can never change the oven clock. And I was thinking what a faff it would be to change the oven clock on Mars, because it wouldn't just be an hour, it'd be an extra minute and seconds, and it would make my head hurt.
I'm not worried about that yet. You're obviously planning for
It's not one of NASA's big concerns at the moment. I don't think they've got their top minds on that, but it's worth thinking about it.
Okay, so let's have a look and see what we will be doing for the next hour. So we're going to catch up with schools that are right here at RAL. They're going to be doing some computer coding just next door. So Dallas will pop next door and see what they're up to. I think they'll be coding some Mars rovers and doing some exploration. So looking forward to seeing how they get on with that. We will see inside the National Test Facility. So we were briefly in one of their facilities earlier to start off with. So they're going to be showing us around a little bit more about how they test spacecraft before they launch them.
It's a really interesting thing. We don't think about that. On the outside world, you don't think, we've got to test the spacecraft. You think, well, I've got to build it, and then you just shove it on a rocket and away you go. The amount of work that goes in to prepare for a launch is extraordinary. Anyway, I learned lots of things today.
There are lots more science facilities here on this campus. We're in Harwell in Oxfordshire, so we're going to go and see some of those. So alongside your activities, you can listen in to some of that. For example, Diamond Light Source, which is a huge synchrotron, a particle accelerator. It's actually just over there, so we drove past it on the way here.
If you don't know what it is, neither do I, but I'm looking forward to finding out. It's got a crazy building. It's like a big donut, like a kilometre, a bit like the Large Hadron Collider, if you've heard of that in Switzerland, but a little bit smaller. And I asked Susie on the way here, I said, what do they do? What do they fire at? What do they do there? No, they fire things around it.
At samples,
That's as vague as it got. We're going to find out more.
We'll be going there shortly. And they use this a lot when they're thinking about the surface of Mars.
Yeah.
We're going to the RAL sister site. So they have a sister site, which is Bulby Underground Laboratory, Bulby Mine, which we mentioned earlier. It's 1.1 kilometers below the surface of the Earth. So we're going to go down there.
Why do we do science down a mine? Just very quickly, like what is the purpose of doing science?
Well, they do particle physics there, but actually we're interested in the environment as an analog to Mars. So we'll be talking to them a little bit about that later on. We're going to go to Goonhilly Earth Station.
We were there last year, or the year before.
Well, yeah,
really interesting.
We chat with them every year. They always have amazing updates for us. So we're going to go to them and have a chat with them about what they're up to in mission control down in Cornwall. We'll be going to talk to Pete Lawrence from the Sky at Night, BBC Sky at Night.
My old colleague on the Sky at Night. If Pete doesn't know it, the answer to the question, that it doesn't exist. Pete has an encyclopedic brain when it comes to the night sky. So there we go.
We'll be chatting with him. And finally, but definitely not least, we've got ESA's reserve astronaut, Megan Christian, who's going to be telling us all about the latest news for the return to the moon.
Yes, she won. Well, she was selected in the last group of ESA astronauts. So she, at some point, hopefully, will be going into space. So she knows all about Artemis and what's going on. So that'll be great.
Yes. So send your questions through to us as ever. We'll do as many shout outs as we can. But to start with, we are going to be going to the National Test Facility right here to explore that a little bit more with RAL Space.
Welcome to the UK's National Space Lab. My name is Sarah and I am the director here at RAL Space in Oxfordshire. Our teams have supported over 200 space missions over the last 60 years, helping uncover the secrets of the universe and using space to benefit lives here on our home planet too. We support telescopes on the ground, satellites orbiting the Earth, and spacecraft that venture out into space. We do lots of exciting projects covering astronomy, exploring our solar system and beyond, observing the Earth from space so that we can better understand the weather and climate change. And we spend a lot of time studying the Sun and its impact on our planet too. We're involved in almost all stages of a space mission. We think of new ideas for missions, design the hardware, build it and test it. We work with space agencies around the world who launch these spacecraft. Then we help to operate them, collect data on giant supercomputers, analyse this data and share scientific discoveries with people around the world. We're doing things that have never been done before, and we're helping others to do the same. One of the ways we do this is by testing satellites here to make sure they will survive launch and their lifetime in space. If something breaks in orbit, it's nearly impossible to fix it, so we make sure it will work first time. We test satellites of all sizes, but the big ones come here to our National Satellite Test Facility. So let's take a look around and meet Charlie, one of our engineers. Hi Charlie.
Hi Sarah. So before we go in the clean room, we need to get dressed up to make sure we don't take any particles or contaminants into the clean room.
Why is that important?
It's important because once something's up in space, we won't be able to clean it. So if you get a thumbprint or anything on a camera, it will remain blurry, which would mean we wouldn't get nice photos from space. So to do this, we wear clean room gown, we wear special clean room shoes, or in your case, special little booties to make sure that there's nothing on the bottom of the shoes that we take in. And you've got your hairnet to make sure there's nothing comes off your head.
They look like the shoes that you wear at a swimming pool.
They probably are the same, but there's sort of similar reasons to make sure that nothing dirty gets into the pool, but here it's a clean room. Welcome to one of our very large clean rooms.
This is amazing, this is huge.
Yes, we can test all sorts of different sizes of spacecraft here, including extremely big ones, sort of the size of a bus. So we need to have very tall ceilings to be able to pick it up and move it around.
So what have we got here?
Here we've got an sample spacecraft. It's what's called a structural test model. So it's sort of the main structure of a spacecraft. It's not exactly what went into space, but it's very similar. So we can test this sort of size as well as a bit bigger. We do also test smaller pieces.
So what's this?
This is a bit of it's an electronics box. So it's got all the sort of electronics and PCBs in there, and you have the connectors coming out, and then it will be connected to a larger piece, such as this satellite.
So this is something that makes a satellite work, and it will fit into something of this size, and then you test it here and it gets launched into space.
Or we can test even just this, because normally every little bit of a spacecraft gets tested, going up in complexity to make sure it all works as expected.
So what does this do?
So these are our speakers, and just behind this big blue door is what we call the dynamics test hall. We do a number of different tests there that are all mimicking the rocket launch, which is very short but very violent portion of the spacecraft's life. So one of the big tests we do is acoustics test, which is we surround the spacecraft with these giant speakers.
These look like the speakers that are at big rock concerts.
They're even bigger than that. But they are, it's the same type of thing. Very big speaker, blasts all sorts of noise at it, the things that you'd see during a rocket launch. All that sound, we expose the spacecraft to it. A lot of the tests here we do to make sure that they're going to survive the environment of launch and as well as in space, to make sure that if anything's going to break, it breaks on the ground where it's easy to fix.
Okay, so what kind of projects have we got on the go at the moment?
So at the moment we've got, we're testing what's called aerial payload. That is RAL Space has been leading on, and that is a exoplanet telescope. So launching in the 2030s, and that will go ahead and sort of search for all sorts of big exoplanets, try and find life elsewhere.
That's amazing. So exoplanets are planets around other stars, not in our solar system, but elsewhere.
Indeed.
And that's brilliant. And that's another European Space Agency mission funded by the UK Space Agency, isn't it?
It is, with led by ESA.
That's brilliant. So we're now in front of what looks like a really big chamber. What's this, Charlie?
So this is the large test chamber. This is where we do thermal vacuum testing. So it gets pumped down, made of vacuum, just like in space, because vacuum can do weird things to materials. So we need to make sure that's all going to be there. We can get very hot and very cold in space, depending on if you're in the sun or not. So again, these chambers can get very cold and very hot. We've just had a bit of the Rosalind Franklin Mars rover just go through. It left today, so that we were kind of helping do a little bake on that.
That's really cool. And that's the European Space Agency mission to Mars, isn't it?
It is indeed.
That's brilliant. So what's the largest instrument that could go into that chamber?
If you sort of imagine like a bus can go in there, it is 12 meters long, 7 meters in diameter. So it is one of the biggest of these types of chambers. It was, I think, the biggest that they could get down the A34.
That's amazing. Wow, so this must be my favourite room so far. Tell me where we are now.
This is known as the electromagnetic compatibility chamber, but it's where we do antenna testing. So it's really important that the spacecraft can be able to communicate either with other sort of things in space, but particularly back down to Earth. So here we can kind of check that. So it's giant, what's called a Faraday cage. So there's a big box of copper to sort of enable, and that combined with all these special kind of blue cones absorbs all sorts of radio waves, microwaves, and other things to simulate being in space really far away from anything like that. And then we have our scanner over there, which then can kind of mimic talking back and forth. We're able to do it in the short, but also kind of mimic being really far away. And it's quite special that we're able to do that far distance away, because many other people have to do it across a giant field.
That sounds amazing. Now, when you're in this room, all of these blue cones make the sound seem really odd. What's going on there?
As I said, so they absorb all sorts of waves, and then one of the things that you can tell is it absorbs sound waves as well as all of these kind of radio waves and microwaves. So it's more known as an anechoic chamber.
That's amazing. Well, thank you, Charlie. Thank you for showing me around the facility. It's been amazing. And it's just huge scale here. And just what I want to get across is how amazing it is in RAL Space. We've got about 350 people working to deliver everything that we have in this facility here, and a lot of other things besides. We've got apprentices, we've got technicians, we've got engineers, scientists, but we've also got skills in communications and creative thinking and business development as well. So there's a whole range of careers and opportunities that we have to rely on in order to deliver the mission of RAL Space. Thank you for taking the time to be with us today.
Thank you, Kate Mulholland, Elle Panton, Holly Coulson, another Elle Panton, Andrea Daniels. We've got so many questions. Oh, King's School in Gloucester, Hollinwood Academy, who have all sent wonderful questions. Oh, I'm a bit cross.
Why?
I'm a bit, because they got to go in the acoustic chamber, and I wanted to do our opening piece to camera in the big spiky blue acoustic chamber.
Yeah, it's a pretty amazing place.
I feel we were fobbed off in the small vibration room. Anyway, what an amazing facility they have here.
Yeah.
They do some extraordinary work.
Yeah.
So I hope you found that
Really
interesting.
important work.
We've got so many questions. I thought we'd do a surprise round, because I'm standing next to Professor Susie Imber, who knows everything about space. So I thought we'd do a quick fire round. Your challenge is I'm going to read you some questions. You can only answer in no more than 3 words. So yes or no, or no more than 3 words.
Right.
Ready?
Yes.
This is from Kate Mulholland. Has Mars got water on it, and can humans live there?
Yes.
Okay, good. That's good.
Can I say anything more?
No, that's the point. Will we ever get to live on Mars?
Yes.
Okay, this is going to be fun. What's the most interesting thing you found on Mars?
I can't answer that in 3 words.
You can. You've got to say something.
I think actually the discovery of water was really important.
Just say water then.
Yep.
Water. Okay, there we go. When are humans planning to go to Mars? We've sort of had that already. What's been the latest discovery on Mars?
Oh, that's really interesting. There have been, too many words.
I give up.
I want to just talk briefly about the water on Mars, actually, because I said it was a really interesting discovery. And actually, it was first discovered quite a long time ago. There are ice deposits on Mars, so water ice deposits at the poles. But there's also been some observations of liquid water under the surface, so lakes under the surface, liquid water, which is really interesting because water should freeze at 0 degrees Celsius. And this water is liquid. Why is it liquid? Because Mars is really cold? Because it's really salty. So while there's fantastic defined liquid on Mars, liquid water, actually it's so salty that those reservoirs of water couldn't really couldn't sustain life as we know it because it's too salty. But really interesting to discover that all the same. Tells us something about past history of life on Mars.
That is interesting. Oh, well, I've got a question for you. Extremophiles, so life on Earth that lives in very, very extreme environments, are much more extreme than we ever conceived. So some life can live in very, very high radioactive areas. We've actually found weird sort of, I want to say bugs, not bugs, but life that's living in kind of nuclear reactors and odd places. And also very, very salty areas. Could we find life in those underground lakes, salty lakes, and on the radioactive surface of Mars?
Well, so not...
Say yes.
No. We actually, a really interesting thing that we do is we go to really extreme environments on the Earth and we try to look for these extremophiles, these very small organisms that are able to survive in the most extreme environments on Earth. They can even survive in space and then come back down to the Earth as well and still be alive. So it's pretty incredible. And we do that research because we want to test our instruments. If I'm going to send an instrument to Mars, I don't know what I'm going to find there. I'm going to use the most extreme organisms we can find on Earth to test the response of the instruments. If this thing existed on Mars, would we find it? And that's a really, really interesting thing that we've been doing for many years. We've been finding extremophiles up in the high mountains for years.
I've got one word for you. Tardigrade. Tardigrades. Google it. Google tardigrades. They've been up in space. They're little water bears. They're called tiny, tiny little creatures, and they live in sort of swampy areas, but they're incredibly resilient. And you can actually take them up into space. They have a little sleep. They sort of hibernate, and then they come back, and they're absolutely fine.
They live all around us. They live in moss. If you get some moss, it'll be teeming with tardigrades.
They may be emotionally damaged. We don't know about that, but they certainly survive okay.
So we're going to move on to Goonhilly Earth Station. Now, we've been to Goonhilly. We've hosted Mars Day at Goonhilly in the past. We went there last year and had a chat with them about their latest missions. And we're now going to go live and have a chat with Jamie Williams, who is Senior Deep Space Mission Operations Engineer at Goonhilly Earth Station. Jamie, are you there?
I am here. It's a pleasure to speak to you both, Dallas and Susie.
Wonderful. Well, we can see you, but we can't hear you.
I am speaking. Can you hear me?
Start off with telling us a little bit about the latest news since Mars Day 2025.
So since you were here last, we've been working on some exciting missions. We have done some lunar landings since we were last spoken to you. We helped Intuitive Machines, a commercial Texan-based company, land on the lunar South Pole last year. And then we have been working on our nominal missions for missions for European Space Agency, missions for the Indian Space Research Organization, ISRO, on their Aditya L1 mission, and also getting ready for some new missions coming up, which I can't speak about what those missions are at the moment, but we've got an exciting 12 months ahead with some new missions in deep space and hopefully some more lunar landings coming up.
You can't tell us about secret missions and then not tell us what the secret missions are. Oh.
Tell us a bit about how you help these missions. If you can't tell us what the missions are, maybe you can tell us a little bit about how Goonhilly helps these missions.
That's a very good point. For those who may not have heard of Goonhilly, what happens there?
So what we do is we're the facilitators of that space to ground link. So we've got a very large 32-meter deep space antenna, which we work with space agencies. So they might need to contact their spacecraft, whether it be in Earth orbit or all the way out to Mars orbit. We have to configure the deep space antenna in the ops room, what you see behind us. This is the nerve center of Goonhilly, where we operate the largest antenna. We'll configure that antenna to the parameters that the space agency or the customer wants. We will get ready for the different frequencies we have to put in, all of the different timings, when we need to start an uplink to the spacecraft, and then we facilitate that link from the customer through us to their spacecraft. We receive all of the scientific data, all of the platform data of the spacecraft, and then they get their data live from us, and we command their spacecrafts.
So basically pretty important. so basically
Yeah,
high stress when things are launched. You're like, oh, where is
it,
it?
it can it certainly can be. All of these spacecraft which are in orbit, they do need communications links to be able to establish comms, to know that the spacecraft are healthy, to get all of that important scientific data and information off them. But particularly when we do something like a lunar landing, particularly for maybe a company or an agency that's this is their first time, it can be quite a stressful environment. But we just have to get our heads in the zone and keep the dish tracking and keep that link between our spacecraft and the Earth established.
And I wanted to ask you as well, business seems to be booming. Every so often we hear on the news another spacecraft, another private spacecraft has landed on the moon. It does seem to be a big sort of upsurge in interest in the moon. I'm wondering if you could tell us why that might be.
Certainly. Well, the access to space has come down as well with more commercial launch providers, bringing that cost per kilo down. So more private companies or academia can now afford to put together either a CubeSat or a small launch vehicle or lunar landers, and get them onto a launch vehicle. And some of them might be rideshare missions where they can split the cost of that launch, and they might also offer payload space on those lunar landings. So they might be able to spread the cost, making that mission far cheaper than it ever has been in the past.
And is there a secret? Do you like the kind of moon missions best? Is there like, oh, we've got a moon mission coming up? Are they the kind of the prize at the moment?
They certainly can be the most fun at the time, but I do have a soft spot for our first mission, what we did, Mars Express,
Oh, yes.
an ESA mission. So I was on the first mission for that when we did our first pass over at Goonhilly. Then we've been supporting that regularly since for the last 4 years. So that's really where my heart lies is Mars Express. Moon missions can be very fun. They can be a little bit stressful, but they don't always last as long because they might have a few day transit to lunar orbit or a few months, depending on the launch trajectory. But they typically last about 2 weeks when if they do successfully soft land on the lunar surface.
Great. Well, thank you very much. We're going to be talking a little bit about Artemis in a moment. And I know, will you be keeping a close, do I say ear or eye on Artemis?
So we are involved in the Artemis 2 mission, that crewed mission to return people to the at least go around the moon since Apollo 17 left in 1972. So we will be providing what's called one-way tracking for the spacecraft.
Okay.
So we'll be locked onto the Orion capsule, receiving telemetry down for that. We won't be transmitting to the Orion capsule. So we'll be playing a role in the Artemis 2 mission.
Great. Well, listen, thank you so much. We missed you guys. We had
Yes.
such fun when we were with you a couple of years ago. Good luck with everything. And we will see you next year, if not before. Thank you very
Thank
much.
you for the
Hopefully
update.
so. And Dallas, just for you, because last year you wanted to see our, if you can see it, all of the
Yes.
missions ever
Oh,
launched.
oh my God, that is my favorite book. They have a printout of every mission ever launched since
Wow.
1957.
Quite a lot.
Since Sputnik 1. Every single
Yeah,
one.
Sputnik. It does house a lot
Thank
of
you.
Starlinks.
Yeah, it's suddenly got, it was like that fat, and now it's like that fat.
It's gotten a lot bigger since.
Look after that book. That's my favorite thing ever. So thank
Well,
you.
thank you very much. It's
All
been a
right.
pleasure speaking to you
Yeah,
both.
we'll
Thank
see
you,
you soon.
Jamie.
We'll see you
Wonderful.
soon. Thank you. Hey,
Bye.
right, who we got next?
We've got McGann Christian, ESA reserve astronaut, joining us to tell us all about the upcoming Artemis missions.
Come on
He's
in.
here in person.
Wow.
Come on in.
Thank goodness I don't. Can I take this wretched thing out of my ear?
Yes.
Which is really annoying. Oh, a human on Earth.
Amazing.
Well, I don't know where we're on a green screen. Oh no, we're on Mars. I see where we are. Hey, thanks very much for stopping by. We've been talking a lot about Artemis 2. It seems to be on everyone's lips at the moment, but it keeps changing. It's going to be this, and it's going to be that. Or we're not going to land. We're going to do this. What's going on?
So at the moment, we've got Artemis 2 coming up.
Yes.
It was originally supposed to launch, a little while ago. There were some problems during the wet dress rehearsal. There was a hydrogen leak. Then they did
sounds
another. It's not great. It's not great. We don't want hydrogen leaking everywhere. Then there was another wet dress rehearsal which went well, but then there was a problem with the helium going through, and so it's had to be rolled back to what's called the VAB, where they build these rockets.
That's that massive, huge
building.
Have you been in it?
I have been in. I was there just about a month ago.
Why aren't I an astronaut? I'm so annoyed. I made the wrong choices at school.
But yeah, so now the rocket is back there.
Yeah.
They're fixing this helium flow problem, and they're replacing the batteries. Then that will be rolled back to the pad.
Yeah.
And we will have the launch again at hopefully in April.
Okay.
So that's Artemis 2.
So that's Artemis 2. And Artemis 2, they're doing a kind of an Apollo 8, if you're familiar with Apollo 8, where they do a little kind of figure of 8 around the moon and back again. So we're not landing on the moon. It was going to be that Artemis 3, the next one, was going to be landing on the moon, but it's not now. They're going to do something else. So.
No, just last week there was an update to the Artemis schedule, and Artemis 3 is actually going to be a demonstration in low Earth orbit. So we're going to be basically testing the different systems, testing the docking with the landing systems, and then Artemis 4 will be the lunar landing.
Like Apollo 9, if you're a proper space geek. They did some in-orbit testings.
Exactly. Yeah.
Maybe you could tell us a bit about some of the astronauts that are going to be on board these missions. Have they picked them already?
So we've got the Artemis 2 crew already.
Oh, maybe Artemis 4.
Oh, Artemis 4, yeah.
Yeah, no, you're quite right. So far, we only know who the Artemis 2 crew are.
Yeah.
And there are 3 NASA astronauts, including a woman and the first person of color, and also a Canadian astronaut. So there are a lot of firsts in this mission, which is really cool. Then Artemis 3, we don't know yet who is going to be on that mission. We know that in some of the future missions, there will be European astronauts on board.
And is it, if we're kind of delaying boots on the moon for a few years now, will there be infrastructure on the moon? So when they get there, there'll be places to stay and things to do? Or is it going to be a bit like Apollo, where we kind of land, do a little bit of science payload, whatever, and then leave again? What's
At first, it'll be like Apollo.
Right.
But the idea is that these first missions will lead towards that. You know, eventually we will have Gateway station orbiting around the moon. We will have bases on the moon itself, and then we will be able to have much more frequent missions. But actually the first landing is not delayed by that much.
Okay.
So it was going to be 2027. It's now going to be 2028. And there are planned to be 2 missions in 2028. I mean, the schedule is always changing, so we don't know if that's really how it's going to be, but that's the plan for the moment.
And actually, this morning we've had lots of questions coming in from people all over the world, and a few of them were saying, how can we watch the launches? Will they be broadcast? How can people see these?
You can absolutely watch the launches online. I mean, if you happen to be in Florida, get close to Cape Canaveral.
Go to Florida.
I do look at the kind of prices. I go on Flight Radar and just check how much prices to Florida, and then I'm really relieved when I haven't bought the plane ticket and it's been cancelled.
Yeah, exactly.
I've saved myself.
Never plan around a launch.
We've got 1 minute. Just very quickly, just tell us about yourself and what you're doing at the moment, because you've got this incredible job. You are an ESA astronaut. You're in the reserve team. What does that mean? Where are you in the pecking order of things?
So I'm doing my training at the moment. I've got another 2-month block of training coming up at the European Astronaut Centre in Cologne, just in a couple of weeks' time.
Amazing.
So really looking forward to that.
Do you get to play in their big sand pit, their big lunar sand pit?
A little bit. So I haven't been out on the sand yet on the regolith, but I have seen it from above, and hopefully that will be coming soon.
Can you steal me some regolith? Sorry, you didn't hear that.
I have some at home. Maybe I'll. Yeah.
I have some as well, which I keep meaning to give back. They said, "Oh, can you give it back?" When I was there, and I have it, but yeah, it's there. Anyway, thank you very much for stopping by.
Yeah, we look forward to following your journey as you train to be an astronaut.
Well, you might actually get to go on the moon. If we're talking about sort of Artemis 4, 5, 6, whenever, then
Could be you.
Well, I mean, if there are going to be more and more Artemis missions,
Yeah.
which is the plan, who knows?
because presumably the space station's going to finish relatively soon.
The
So we
space
need-
station is planned to be doable at around 2030. Then there'll be commercial space stations, but the lunar missions are ramping up, so who knows?
Amazing. There you go. You heard it there first. Thank you very much, McGann Christian.
Thank
you
you.
very much for joining us on our Mars Hour.
Thank you both.
Right.
Thanks.
What have we got next?
Wonderful. That was fantastic.
Yes.
Wonderful to hear from someone who might actually be on the moon a few years from now.
I'm so jealous.
I know.
No, I don't need to go to Mars.
Look, we're on the moon. It's
I
fine.
don't- Oh, there we go.
We're
thank
on
you.
the moon.
But just a weekend on Mars would be nice. On the moon would be nice. 'Cause
We'll
then
work on that.
you can see the Earth.
Mars Day from the moon one day, live from the moon.
Budgets will be stretched, but I think we'll talk to Angie over there. She'll sort that out for next year.
So we are moving on to talking with Pete Lawrence, who's from the BBC Sky at Night.
Love Pete.
Yes. Pete, are you there?
Oh, I better
I'm
put my
here,
little,
yes.
Wonderful.
my little thing in. So I can hear.
Fantastic. So for those of you that aren't familiar with the Sky at
Hey.
Night, maybe Pete can briefly introduce it and maybe share some slides with us and tell us a little bit about the night sky right now.
Yes, indeed. I wanted to talk about Mars, observing Mars, actually what it's like. I've been observing Mars for many, many years, and the best time to see it is when it's really close to the Earth. And that's not where it is at the moment. It's at the moment very close to the position of the sun in the morning sky. It'll take a little while for it to actually get into a position where it is looking good. And then it will start to move into the darkness of the morning sky. That's probably going to be around about August time. It's an amazing planet to see with the unaided eye when it does this, because it has this beautiful, I always describe it as salmon pink color, and it looks like an ember glowing against the stars. But the best time to actually observe it is what's called opposition, and that's when it is in the opposite part of the sky to the sun. So there is a line joining the sun through Earth and onto Mars. Mars is up all night at that particular time, but also the distance between Mars and Earth is minimized for the current period of visibility. Now, not all oppositions are equal. Some are better than others, and that occurs because Mars has an elliptical orbit. In an elliptical orbit around the sun, there is a point which is closer to the sun, that's called perihelion, and another point which is furthest from the sun, which is called aphelion. When you have an opposition of Mars which coincides with perihelion, the distance from Mars to the sun is at a minimum, and also the distance between Earth and Mars is at a minimum. So if you look at Mars through a telescope, it looks bigger than any other time. And that's the best time to see wonderful detail on Mars. When Mars is at aphelion, things aren't so great. It still looks bigger than it does at other times, about 3 times larger than when it's not at opposition. But it's not as large as it would be if it was at perihelion. A perihelic opposition gives you Mars, which is about 6 times larger than it would appear normally. So perihelic oppositions are the best. Aphelic ones aren't so good. There is a counter to that from the UK, because perihelic oppositions occur with Mars being very low in the sky, and that makes the planet much harder to observe. Aphelic ones have it really high in the sky, and you get much stabler air then. Looking through a telescope, you get to see fine details, even though it's a smaller disk. The next opposition occurs in February of 2027, and you probably guessed it, it's an aphelic one, so it will be one of the smaller ones. There is another thing I should mention. When you get a perihelic opposition, when Mars is closest to the sun, that's when the radiation is most intense coming from the sun, and that's when you can get intense dust storms kicking off, and they can obscure everything on the planet. So even though it's closer and we get a bigger disk, you might not see everything because of the dust storms. Now, when Mars comes to opposition, it does something quite amazing. It comes from the west to the east in what's called prograde motion. It trundles along, and then about 5 weeks before opposition, it slows down, comes to a stop, and then reverses direction to head in a retrograde motion. This is when it's starting to head towards opposition. It moves backwards across the sky for about 2.5 months, comes to a stop, and then reverses direction to go prograde once again. Because it forms a loop, and that loop occurs when the planet is moving in a retrograde sense, it's called a retrograde loop. So what's happening is Mars actually changing direction. No, of course it's not. What happens is the Earth, which is moving faster in its orbit, manages to overtake Mars. So if you draw a line from the Earth through Mars and plot it against the background stars, you'll see how it forms this amazing loop. All the outer planets do this, but the one for Mars is particularly striking. Now, the first time I ever observed Mars was when I had my first big telescope. I made it myself, and the view I got was frankly a little bit disappointing. And that's because my eyes hadn't been trained to look at Mars. You need to give yourself time when you're looking at astronomical objects to get used to the view. But when I did that, eventually I started to see detail. I could see this little bright patch at one end of the planet, which is one of the polar caps. And after a while, that became quite intense. It's a very striking color difference between that and the surface. You can also see dark markings on Mars, and these are regions where you've got bare rock. The pinkish regions are where you've got the sands of Mars, so the deserts of Mars, if you like. And they become very familiar over time when you are observing Mars. This sequence here, which I hope you can see, is a number of photographs of Mars I've taken through my own back garden telescope, and I've just put them together to show how Mars rotates throughout a session. There's no color here because this was using a black and white camera, but you can see there's loads of detail visible. The other stuff you can see are hazes on Mars. So here you've got the polar cap at the bottom, and then you've got these hazes either side. And those are hazes in the atmosphere of Mars. So you can see Martian weather. This bright patch in the upper left corner of Mars, if you like, is actually frost, which has formed in the Hellas Planitia Basin. This is the largest impact basin on Mars, 2,300 kilometers across. So you can see different weather over different seasons on Mars. So Mars is a fantastic planet to observe. I find it sometimes a little bit frustrating because with oppositions occurring every 2.1 years, you have to wait quite a while before it gets into a good position to get a view of it. Also, if you're observing it, say at 10 p.m. on one night, and you go out and you get a view of Mars, because Mars rotates once every 24 hours and 40 minutes. If you go out the next night at 10 p.m., Mars hasn't quite got back to where it was the night before. It's got an extra 40 minutes of rotation to go. So you basically, from one night to the next, you see a little tiny extra bit of Mars before you get a rerun of what you saw the night before. And that can be a little bit frustrating over time because amateurs, or amateur astronomers, I should say, rather unkindly say that there is one side of Mars which is the boring side of Mars because it doesn't have many of these dark markings. It's not boring in any sense of the word, really. It's just that you can't see much detail there. And it always seems to be clear when you've got that side of Mars facing you. So that's my experience observing Mars. If you want to find out more details, I'm sure as we get through later into the year, we will mention it on the Sky at Night, which next transmits on, I think it's the 13th of April.
Very, very much, Pete. It's lovely to see you. And actually, yes, if you want more, Pete, don't forget to tune into Sky at Night. Sky at Night, longest running television program ever in the world. It's been running for 13.5 billion years. And Pete's been he's been in every single one. He's very good. He is a very good moisturizer.
Thank you so much, Pete. That was wonderful.
It's a pleasure.
All of you out there who've just been inspired, you can go and join your local astronomical society who will have telescopes to let you go and see the night sky.
And just use your eyes. You don't even need a telescope. Just look up. You can actually see Mars sometimes.
Well, that's true, but if you want to see the features, it might be handy to have.
A pleasure.
Great. A quick shout out to King's School in Gloucester. Thank you very much. They want to know how you get a career in building Mars rovers. The answer will be this afternoon when we talk to through our different career sessions to some people who have just transitioned into the space industry. How did they do that? What did they study? How did they find their path? So
I'm going to meet some young people who are going to be building rovers in a minute, I think.
Yeah, so hopefully lots of you are doing activities right now as it's Mars Hour. So we'd love to find out what you're doing. Do send us photos of your creations, your ideas. We'd love to see those, and we'll do more shout outs as we go.
Yep.
Right now, though, we're heading off to the Diamond Light Source, which is the synchrotron on site right here, an incredible building. Let's find out how it can help us explore Mars.
Hello, welcome to Diamond Light Source. My name is Dr. Stephen Thompson. I'm the Principal Beamline Scientist here on Beamline I-11, and I'm going to tell you something about the research we do and looking at understanding what goes on beneath the surface of Mars. We don't have the whole planet. What we do is make a little model of it, and it sits inside this little capillary tube here, and what we put in here is salty water, reminiscent of what the oceans on Mars may have been once, and we freeze it because Mars is now very, very cold. And once it's frozen, we pump high pressure gas into it, and that changes the structure of the ice from ice into something called a clathrate, which is what this thing here looks like. This is a model of it, and as you can see, there are lots of holes in it. There's cages, big ones and little ones, and those cages trap gases such as carbon dioxide and methane. On Mars, there's also salts such as sodium chloride, the stuff you put on your food, calcium chloride, magnesium chloride, and they act as a bit like an antifreeze. When they come into contact with ice or these clathrates, they cause them to melt at certain temperatures. And what we're interested in is the effect that the different salts have on the temperatures at which these clathrates melt. Because when they melt, they release all the gases that are trapped inside of them. On Mars, there's a thing called the cryosphere, which sits below the ground because the surface of Mars is very cold. So below ground, there's this frozen cryosphere, this region which is made up of ice and clathrates. It's thicker at the poles, thinner at the equator, because obviously the equator is warmer. And as the temperature varies throughout the seasons, just like it does here on Earth, the temperatures rise and fall, and the clathrates fall apart, they melt, and they release their gases. And what we found is the different salts affect the temperatures at which that happens. Now, we know that on Mars there are seasonal outbursts of methane coming from the surface. The dissociation of clathrates could be the cause of those things. Another important aspect is that there could be life on Mars. If there is life, it's going to be beneath the surface because surface conditions are very harsh and very cold. In the last couple of years, it's been discovered that certain microbes can produce antifreeze proteins which bind onto ice and onto clathrates, which stop them from growing and can cause them to melt. Now, there are some microbes that use carbon dioxide as a fuel and produce methane. There are other microbes that consume methane and produce carbon dioxide. Now, we don't know if there's any life on Mars, but clathrates and their dissociation could represent an important energy source, a food source, if you like, for them. Because in recent years, the last couple of years, they've discovered certain microbes on Earth that are cold adapted, produce what are called antifreeze proteins. Now, these proteins bind to the ice and to the clathrate. They stop it growing further, but they could also help it melt, especially when salts, for example, are present and the temperatures vary, and the release of those gases could produce an important food source or energy source for those microbes beneath the surface. Now, beneath the cryosphere itself, further down, is a layer of liquid groundwater, as believed, and as the temperatures change throughout the year, that groundwater goes up and down towards the surface and back down again. So what you could have are pockets or subterranean lakes or little reservoirs, channels, whatever, full of liquid water, salty water that microbes can live in. Now, two things happen here. When those waters get colder, the salts themselves can come out of the solution and form solids, precipitations as we call it. And the precipitation salts on Earth, for example, controls the ecological habitats of cold adapted microbes living in the polar regions on Earth. Because when the salt comes out of the water becomes more pure water, which is conducive to life. So the melting of clathrates in the presence of salts could provide food source and energy supply to subterranean colonies of microbes where the salts within those environments help regulate their ecological environment. Now, we don't know if there's life on Mars, but this is one place we could possibly look.
Pilot ready? Mission specialist ready? 5, 4, 3, 2, 1. We have liftoff! On astronaut training days, the living room wasn't a living room at all. It was the moon. Their teepee leaning against the sofa was their rocket, complete with cardboard control panel. Leo and Luna zipped into their astronaut gear, winter gloves on, bike helmets snug. Luna jumped out the rocket first. Whoosh! She hurled a cushion across the room. Asteroid! She shouted. Leo squealed and ducked just in time. This is the best training ever, he giggled. Luna leapt from the sofa arm. Boing! Onto the fluffy white rug. Wow, she laughed. On the moon you can jump so high. They practiced pressing buttons. They practiced counting down. They practiced leaping across the carpet like astronauts in big clunky suits. But it was all pretend, or so they thought. Beep, beep, beep. The cardboard control panel blinked. That had never happened before. A tiny red light, definitely not made from buttons, flashed. Incoming message, crackled a friendly voice. Astronauts needed. Destination, the moon. Mission, collect lunar rock sample. Leo and Luna stared at each other, eyes wide, hearts thumping. This was no longer practice. The rocket rumbled and shook. Leo and Luna were flung into their seats. Up they zoomed, up, up, past clouds, past blue horizon into deep, sparkly black. Wow, whispered Luna. What a view! And then they were weightless. Whoa, shouted Leo as he floated towards the ceiling. Seatbelt, Leo, Luna laughed, and don't lose the astronaut snacks. Leo gently pushed off the ceiling. Together, they grabbed the snacks. In weightlessness, teamwork mattered more than strength. Watch out! Meteor maze! Shouted Leo. Left, right, duck! They zoomed and swerved past spinning space rocks, some tiny, some huge. Then, wham! The rocket spun and spun and spun. They weren't even at the moon yet. They were nearly space debris. Luna's face turned green. She had space sickness. Leo looked worried. You don't want to throw up in 0G. Just then, the moon appeared below them, pale and cratered, like a giant scoop of ice cream. Scrunch! They landed. Outside, everything was quiet. No wind, no sound. They hopped down, leaving dusty footprints behind. Leo chose a small, smooth moon rock for his sample. He threw it gently to Luna. It went high, up, 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 sailing through the sky like it was flying. It made a long, gentle curve before coming back down, landing softly on the ground without a single sound. The moon's gravity is much weaker than Earth's, Luna said with a smile. That's why you can throw things so far, she explained. The soil is called regolith, said Leo. It's made of tiny broken rocks. Where should we go now? They spotted dark, flat areas called Maria, formed long ago by lava, and bright highland mountains, and a surface covered in craters from very, very old collisions. They bounded across the surface, passing craters, bounce, bounce, until the ground suddenly rumbled. A moonquake! The surface cracked near a deep crater. Luna slipped. Leo remembered some of their astronaut training and the importance of teamwork. He grabbed her hand just in time, and together they scrambled to solid ground, hearts thumping. Never explore alone. Let's go home, they agreed. Where are we now? Pass me the moon map. Oh no, we forgot to bring it with us. What are we going to do now? Leo's eyes filled with tears. It's okay, Luna said gently. We can make a new one. We've got our sample, explored, and learnt about the moon as we've gone along. As Leo began to feel a bit better, they noticed something strange. Shadows stretched across the ground in sharp shapes. Moon shadows were much darker and much clearer than on Earth. Look, Luna whispered. The shadows make patterns. Tall crater rims pointed one way. Mountains cast long triangles. The sun's position was leaving clues. Using everything they'd learned about craters, Maria, highlands, and shadow directions, together they drew their ideas in the moon dust. This highland curves like a smile, and this crater is shaped like a splash. We need to take a left at this Maria to get back on track. That shadow points to the right. They hopped, turned, and counted craters. The rocket appeared just where the map promised. It worked, they cheered. They climbed in, clutching their map, and blasted off toward Earth. With a gentle thump, they landed back in the living room. The rocket was a teepee again. The meteors were just cushions. The cardboard control panel went quiet. But the adventure would stay with them forever. As Leo and Luna exited their rocket, Luna proudly stuck their moon map up onto the wall. A forever reminder that with curiosity, courage, teamwork, and a bit of astronaut training, you can get all the way to the moon.
Thank you very much, Mission X. Thank you very much to McGann as well for reading us that story. Astronaut and bedtime story reader. I mean, she is multi-talented, so thank you very much for that. Now, I've come out of our little studio into the visitor centre here at RAL Space because there's stuff going on. And here to explain what that stuff is Will. Hi, Will.
Hello.
Will, you are a senior human. That's as far as senior
Systems administrator.
Senior systems administrator. What does that mean?
So we have a big data center over on the other side of site, and it's we have multiple supercomputers there. I work on one of them, which is called Jasmine for Climate Science and Environmental Research. So people like the Met Office and National Environment Research Council use it to predict weather, earthquakes, and this kind of thing.
I want to go and see it. Can we just go and see it?
No, well, yeah.
When I think of supercute, I imagine a kind of big oak door that creaks open, and inside there's kind of smoke and a kind of low whoa, whoa, whoa.
There's definitely the low whoa, whoa, whoa sound. If there's smoke, then I'd be running over there now because that probably means there's a problem. Okay. Yeah.
No problems with the supercomputer. What's going on in here? We've got loads of kids doing things with computers.
So we've got these little robots that are. Grab one of these. They're made of Lego. They've got this color sensor here that the students here are programming. So we're getting them to do a few challenges using the color sensor. So to find water on Mars, or actually to go forwards and look at a blue line, and to count the number of lines and to follow a line as well, all using the color sensor.
Amazing. So why don't we go and talk to some of these fantastic students here and find out how they're getting it. Now then, what's your name?
Connie.
Connie.
Charlotte. And Victoria.
Connie, Charlotte and Victoria. So you've got a computer. I'm familiar with one of these. I've seen one of these before. But this, on the other hand, my goodness, what's going on here? So, Connie, tell us what's going on.
What we've programmed is for it to move 30 centimeters forwards. So.
Now, when you say programmed, what do you mean? So I'm looking at a screen and there's lots of colourful things. What are those colourful blocks?
So those are like the items that you use to program your machine, your item.
Okay.
And for example,
that's like the instructions.
Yeah, basically. For us, it's our Lego robot.
Okay, so what have you programmed? What have you programmed it to do?
To move forward, 30 centimeters.
And do you know?
Change it as well.
And do you have plans for it? What's the plan for today anyway? What are you going to try and make it do?
What we're going to try and make it do is we're going to try and sense colours. So it'll move forward, sense the colour, and then kind of in some ways be like, okay, there's water here. We've detected that there's water here. Stop, and then maybe alert other people, kind of things.
That's amazing. And do you think it will be able to? If we put some water down, would it be able to detect it?
I think probably it might be able to detect it, yeah, because it's quite smart.
I think so, because there's a colour thingamajig. No, it's here. And it can detect, when there's water, it can probably see it or by the camera.
One of the words you mentioned is this idea of water. Why do you think water is so important? Why is looking for water if we went to another planet? Why is that important?
Because water's important to our lives. We drink water every day. And we it's just important.
It could be a different type of water, maybe new discovery or something like that.
Also, it's a basic function of human life. You can't survive and thrive without water for a day, maybe. I think possibly a couple of hours.
Yeah, I think you're right. I think everything that we know about life originally kind of comes from water. Okay, this is the really boring grown-up. This is a question grown-ups always ask. What do you want to be when you grow up? Is this fun for you? Do you think you're gonna work in
Definitely,
the space industry?
I mean, my parents are they work in the scientific kind of, well, not scientific, but more computer scientific area, computer science and yeah.
What about you two?
I don't really want to work in the space industry, but I do want to work in the animal place. I want to be a naturalist when I'm older.
That's a naturalist. That would be a really nice thing to do, looking after planet Earth. And what about you? What's your big goal, your dream?
I think I'm same with her because I love animals, but for a vet you need to know a lot of scientific stuff, like medicines and how to heal animals.
Fantastic. Well, listen, good luck. Enjoy programming your Mars rover. I hope you find life on Mars. Someday, this is where it all starts. Eventually, it'll be people just like this, doing things just like that, will go on to discover life on Mars. In fact, there is Mars, just up here, in between Jupiter on Earth. Back to you, Susie, in the studio.
Wonderful. Thank you so much. And I hope everybody out there has had fun doing their Mars Hour activities. We're approaching the end of Mars Hour, but we aren't there yet. Before we get to the end, we are going to go to Ral's sister site, which is called Bulby Underground Laboratory. It's in a mine, 1.1 kilometres below the surface of the Earth. And I'm going to throw you over to them for a tour of their facilities.
Hello, everybody. Hope everyone's having a nice Mars Hour so far. It's a pleasure to virtually meet you. My name is Johnny, and I'm joined by my colleague here, Beth. And for the next 5 or 10 minutes or so, we'd like to show you as much as we can of our deep underground science facility. So let's set the scene. I am talking to you now live from 1.1 kilometers underground, from the deepest mine in Britain. That might be hard to believe looking at Beth. Beth doesn't look like she's a kilometre underground. I perhaps do, however, because we have this deep underground science facility called Bulby Underground Laboratory. And there's lots and lots of science that you can do by being deep underground. It's a strange niche for science, but it's a really important and special one. And there are 4 kind of pillars to our science program. 4 areas which our science program covers. And one of those 4 areas we'll be talking about for the next few minutes. And that is space exploration and planetary exploration science. So where I am right now, this is just outside the front door of our lab. Beth is through a door that's that way. And this is our outside experimentation area in the tunnels of Bulby Mine. And this environment that I'm currently in now, maybe it doesn't translate over camera so well, but it's what we might call a demanding or extreme environment. It's a harsh place for people and robotics to be. So where I currently am, it's about 35, 36, 37 degrees Celsius. So it's hot. It's like one of the hottest summer days you can probably remember. It's also salty. Because the rock, the floor, the walls, the ceiling, all of this rock around me is salt, 250 million year old salt. And this salt turns to dust, turns to a very fine dust quite easily. So it is quite dusty down here. And the terrain is unpredictable. We are in an active mine, after all. So this space behind me, our outside experimentation area, or as we tend to call it, the Mars Yard, is a great place to test robotics before sending them to demanding environments, such as the surface of Mars. So much like how you might take a Mars rover to a remote place like a desert to try and test it and benchmark it and put it through its paces, you can do the same thing by bringing your robotics down here into Bulby Mine to Bulby Underground Laboratory. So we've tested robots from NASA, the European Space Agency, and countless universities and institutions in this space behind me, and also elsewhere in the mine too. But being underground for space exploration is more than just that as well. You know, this salt that surrounds me now, this salt rock, was formed when an ancient sea on the supercontinent of Pangaea evaporated, leaving behind a layer of salt, which is now buried a kilometre underground. And that ancient sea, that very, very salty ancient sea, might have had microbial life in it, the chemical remnants of which we might be able to see in small pockets of brine, small pockets of salt water, trapped in the salt crystals in the salt rock like this. Mars might have once had liquid oceans, which might have once harboured life, microbial life. And those liquid oceans have since evaporated, potentially leaving behind deposits very similar to the ones that we see down here in Bulby, which means that you can practice looking for life on Mars. You can develop techniques for looking for life on Mars down here underground first, before you then try and do it on another planet, which this whole space exploration science thing might seem counterintuitive. Space is up there, we're all the way down here, and yet they go hand in hand in such a brilliant way. But we don't just do research out in the tunnels of Bowlby Mine. We also have a very clean interior laboratory space where Beth currently is, where we can do lots and lots of other sorts of science too. Beth, do you want to say a few words about that?
Hello, thanks, Johnny. So I am in our main lab area. At the end, you can see the LEC, which is our large experimental cavern. And this lab is lined with different science experiments. But why do we have a lab underground? So on the surface, there's so much cosmic radiation from the sun that the detectors and the science that we do down here wouldn't work. So we need to come deep underground. We actually experience 1 million times less cosmic rays underground, and that gives us the perfect environment to do low background particle searches like dark matter searches, and also materials screening, quantum technology, muon research, and low radiation biology experiments. So the work we do here can only be done here. We are the only underground lab in the UK, and we are one of about 12 in the world. So this is a really unique facility for the science that we can do. So thanks for looking at our lab. I'm going to pass you back to Johnny for some questions now.
Thank you very much, Beth. Fantastic. So do we have any questions? We have a few minutes now, I think, to answer a few questions about anything underground sciencey.
Hey, thank you so much for that. Many years ago, I went down Bowlby Mine, and there's more things happening in Bowlby Mine than when I was down there.
Yeah.
I ended up mining potash down there.
Ah, do they still do that?
Yeah, do they still do that?
They don't mine potash anymore. Here's some potash. I've got a piece that I can show you.
Tell us what it is, actually.
So potash is a type of rock that's mined all around the world, and it's used as an agricultural fertilizer. And when Bowlby Mine first opened, this is the stuff that they were mining. It's quite red in color.
Yeah.
Its main component is potassium chloride, I believe, but they don't mine potash anymore. The mine that we're based in, they now mine polyhalite, which is this stuff.
And what does that do?
It's also an agricultural fertilizer.
Okay.
They're mining knowledge. That's what they do down in Bowlby Mine.
So the mine existed because they were mining other things, resources, and then you guys moved in to do some science. Is that right?
Yes, that's right. It was in the 1990s. Some scientists, I believe it was from the University of Sheffield, wanted a space underground to do some particle physics experiments, specifically looking for dark matter.
Yeah.
Coming underground is a great place to do that.
I don't think they found it yet, annoyingly.
Well,
no.
The question isn't answered, that's for sure. Yeah. So how much of the mine is actually science and how much is just ongoing mining activities? How much space are you guys taking up?
We don't take up a lot of space in the grand scheme of things. The laboratory that we have, the space that Beth's currently in, is maybe about 100 meters from end to end. And our outside experimentation area where I am, you can see, is maybe 100 meters from that curtain back there to our front door. So in the grand scheme of the mine, which is absolutely ginormous, it's about 7 kilometers end to end. We are only but a small part of it.
So there you go. If you want a career in space, you don't have to just go up. You can you can sort of journey to the center of the Earth and do some interesting stuff down there.
Amazing. So actually, how long does it take to get down there? I have lots of questions about that.
Well, there's a lift that goes down.
Yeah, how long is that journey?
5 minutes.
Yes, so it is a lift. It's a lift that we call the cage. It's like a big industrial lift, and it takes about 6 minutes.
Okay, and on a normal shift, how long do you spend underground?
So us at the lab, we usually catch the 9 a.m. lift ride down, and then we tend to come back up on one of the 2 p.m. rides, but there is the option to stay down until 5 p.m., which we don't do all the time, but you definitely need to make sure you remember your lunch if you do that one.
Yeah, you can't pop to the shop.
No, do we have any? Have we got any Bowlby questions from
let's have a look. So yeah, here's one. Why is Bowlby the only place like this in the UK?
Yeah, good question.
It's from Ben in Year 8.
Thank you, Ben, Year 8.
Very good question. So underground labs are a rare thing. Only 12 or so countries in the world have an underground lab. We're lucky in the UK to have one. And we're simply the only one because we're the only one that there is. We're in the deepest mine in the country, so we can't get much deeper than where we currently are.
And if you could get deeper, would that be better for your science, or is 1.1 kilometers enough?
It depends who you ask. If you ask a particle physicist, they might say that the deeper you go, the more cosmic ray attenuation you'll get.
Needy particle physicists.
Yes.
They're always needy.
But then you may not have access to this interesting geology that allows us to do all the space exploration research that we do. So if you were to ask one of those people, they might say that being deeper is not as good.
There we go.
Very interesting.
I'm being told we're out of time. Am I right? We're out of time. Listen, guys, thank you so much for taking the time out of your busy science day to join us. It's been absolutely fascinating. You have opened a new window, I think, for lots of people.
Yeah.
Who now know that we can do all this extraordinary space science and particle physics.
Yeah.
And fertilizer mining all in one place. There we go. So thank you very much indeed.
Thank
a
you
pleasure.
so much. Yeah, pleasure to speak to you all. Now, don't forget. Bye. Don't forget to send in questions, of course. There's a Q&A, so type your questions into the chat. We'll get to as many of those during the sessions as we can.
Yep.
But you can also hashtag Mars Day 26 if you want to sort of put a hashtag in your social media.
That's the
words out. So that's available to you. You can check out the Mars Day website. There's also lots more ideas for things you can do following on from Mars Day activities and things like that. So there are lots of resources there. The link will be in the chat.
I've just noticed we've got Earth time and Mars time ticking away at the same time. I hadn't noticed that.
We do, and actually there's only 10 seconds left of Mars hour.
No way, but we get an extra second because we're on Mars.
We get an extra 1 minute and 38 seconds.
That's what should we do in that 1 minute, 38 seconds?
Well, I think we're using it up right
okay.
now, actually.
That's it, okay.
So yeah, that's it. That's it for Mars Hour. Mars Hour is just finished. The Earth Hour finished a while ago, but Mars Hour is just finished. So that's the end of your activities, but do join us for the rest of the afternoon. We've got some really great sessions now with ESA, and we're doing some careers sessions this afternoon. So do stay on the line here. One link for the secondary schools for the whole day. Primary school links go in the chat because they're in a different place.